Nest.js comes with a built-in exceptions layer responsible for processing all unhandled exceptions across our application. When an exception is not handled by our application, it is automatically caught by this layer, which sends the appropriate user-friendly response. Out of the box, this action is performed by a built-in global exception filter. While this base built-in exception filter can automatically handle many use cases for us, we may want full control over it. For example, we may want to add exception logging or return our errors back in a different JSON schema. Exception filters are designed for exactly this purpose. They let us be in charge of the exact flow of control and the content of the response being sent back to the client. Let's create an exception filter that is responsible for catching exceptions that are an instance of the HTTP exception class, and implement our own custom response logic for it. Let's get started by firing up our terminal and generating a filter class using the nest-CLI filter schematic by entering nestgfilter common/filters/http-exception. Note that we generated this filter in a common directory where we can keep things that are not tied to any specific domain. Let's open up the newly generated HTTP exception filter and see what we have inside. As you can see, the nest-CLI generated an example filter without any business logic, of course. The catch decorator on top binds the required metadata to the exception filter. This catch decorator can take a single parameter or a comma-separated list. This allows us to set up a filter for several types of exceptions at once if we wanted. Since we want to process all exceptions that are instances of HTTP exception, let's pass the HTTP exception class between the parentheses. All exception filters should implement the exception filter interface exported from nest.js/common. This interface requires that we provide the catch method with its indicated method signature. Also, we can see that our class accepts a type argument, which indicates the type of the exception argument in our catch method. Again, since we want to process all exceptions that are instances of HTTP exception, let's change this to t-extends HTTP exception. Alright, with all of that set up, now we can implement our custom response logic. To do this, we'll need to access the underlying platform's response object so that we can manipulate or transform it and continue sending the response afterwards. So where do we get a hold of the original response? Let's use the second parameter here, host, which we can see as an instance of arguments host, and call the method switch to HTTP on it, saving this as the variable ctx, short for context. This switch to HTTP method gives us access to the native in-flight request or response objects, which is exactly what we need here. Next, let's use this ctx variable and call the getResponse method on it. This method will return our underlying platform's response. Remember, in Nest.js, this is expressed by default, but could also be swapped for Fastify. For better type safety here, let's specify the type as response, importing this type from the Express package. Now that we have our response, let's use the exception parameter available to us in this method and extract two things, the status code and body from the current exception. To get the status, we can simply call the getStatus method as we see here. Let's also get a hold of the raw exception response by calling the getResponse method and saving that to a variable as well. Since for demonstration purposes, we're trying to pass back this original error response, we need to do a little bit of work here. First, we need to test whether the response is a string or an object. If it's a string, we're going to create an object and put that string inside of the message property. Otherwise, we're all set, and our exception response is already an object. By doing all of this, our errors will now be fairly uniform, and we can spread this error variable into our final response, which we'll do in a moment. Great, so now that we have everything we need, let's start building our response back that we'll be sending. First, let's set the status code for the response we're going to send back via the status method. Lastly, we need to send the exception response back. Our application's underlying platform is Express, which is the default. There are several ways we could do this. In our case, let's just use Express's JSON method. We can simply chain this method after our status call as we see here, and using the spread operator, we can pass the original error from our exception inside of this JSON method. As of right now, our exception filter here isn't really doing anything unique yet. So let's pass in something custom here along with the original exception. This way we have something we can look for in all of our errors to make sure everything with the exception filter works. Let's add a new timestamp property and give it the value of new date to isostring. Great, now with all this in place, let's bind this global exception filter to our application. Since we don't need any external providers here, we can just bind this exception filter globally using the app instance in our main.ts file. Let's head over to the main.ts file and add it real quick with app.useGlobalFilters, passing in new HTTP exception filter inside. Now that everything's in place, let's test it out by triggering some API errors. Let's make sure that our app is running in our terminal, and if not, make sure we run npm run start:dev again. With our application running, let's open up Insomnia and perform a GET request to a non-existing resource and purposely make an error happen. Let's hit something like coffees/-1, where -1 is obviously an ID we don't have in the database. As we can see, the response came back with an error and clearly used our new custom exception filter, since the response contains our new timestamp property. Perfect. So naturally, this exception we created was a basic example implementation. But you can see that within this exception filter, we could have just as easily used some sort of logging service to track our errors, maybe even called an analytics API. Anything we'd want to do whenever an HTTP exception occurs in our applications.